X bar means mean. Yes, you guys are so smart. Okay, so we're going to stick step 1 into our notes right there. The first step in finding standard deviation is calculating the mean, X bar. So over here I'm going to write, we're actually going to use data set 1 from the front. So I'm just going to copy these values into my chart. I highly recommend using a chart for calculating standard deviation to keep things organized. So my X values are 1, 1, 2, 2, 5, 5, 8, 8, and 9, 9. Find the mean, just add them all up and divide by how many there are. So go ahead and, you can go ahead and calculate that. And there are 10 numbers. What do you get? Add them all up, divided by how many there are. What'd you get? 5. Yep, so 50 divided by 10, which is 5. X bar equals 5. The next step is to subtract each of our observations minus the mean. So we're going to go down and do 1 minus 5, which is negative 4. 1 minus 5. This is that part where I said, hey, this is a tough process. This takes some time. It's got 5 steps, and there's repetition. This is the repetition piece. So I highly recommend when you're doing this, try and get in the zone and focus, because otherwise you'll start subtracting the wrong numbers, like I did during my second period. If you don't focus, you start subtracting the wrong things. So that was step 2. These values in this column are all called deviations. Okay? Deviations from the mean. All right? This is the whole process of finding measures of variation within standard deviation, is to find how far on average the observations are from the mean. You're going to glue step 2 in right below where you calculated the mean. We're going to need some space here. And all of this is specific to sample standard deviation. So it's a data set collected from a larger collection of the population. Next step is to just square all the deviations. So we're going to take each of these answers and square them. So negative 4 squared is 16. Don't forget to use parentheses around negative numbers when you're calculating this. So that was step 3. You can go ahead and glue that in right below step 2. I should draw an arrow. Step 2 is over here. Step 3 is right here. And then we're just going to find the total of all of these squared values of the deviations. Anybody calculate that? Little mental math. You got some 16s and some 9s. It's 25. You got 4 of those. You got 100. The total is 100. So step 4, drum roll. Good drum roll, thank you. That's nice. Well done. You guys are way better than me. Calculate the mean of the squares, aka the variance. The variance uses the letter lowercase s for sample standard deviation, and we're actually going to divide by n minus 1, which is a little funky. We do that because it's the sample standard deviation, and since we're talking about a part of the population, we're going to make inferences. We're going to use to make inferences about the total population. Dividing by n minus 1 gives us a little bit of extra cushion. If you're interested in learning more about and understanding that better, I'm glad to talk to you more about that. Otherwise, you can just trust me. We divide by n minus 1 when it's the sample standard deviation. Thanks. So this looks like taking our 100, which is calculated, divided by n minus 1, divided by 10 minus 1. So 100 divided by 9, which is 11.11. Oh, I'm so sorry. The variance is s squared. Where standard deviation is s. So please add the squared to your notes. Variance is s squared. Sorry, I forgot that earlier. Step 5 is where we're going to calculate the standard deviation. This is the last step. Step 5. You got this. It's it. This is it. Okay, so take the square root of the variance to calculate the standard deviation. Standard deviation gets the letter lowercase s. So it makes sense to get from step 4 to step 5 that we're taking the square root of s squared. We're taking the square root of our 11.11. Which is 3.33. It's an S. That's the symbol for standard deviation is a lowercase s. Me? Yikes. I'm going to work on my self-conscious about my lowercase s's now. Lowercase s equals, we wrote this formula on the board earlier, the square root of the whole thing all in one, the sum of all of the x minus x bars squared, all of the deviations squared, divided by n minus 1. That's it. That's the formula. So our second bullet point, you know these come up on Math Excel, right? Whenever you got word questions, I try and help you out and include those words right here within the context. Having a high standard deviation for a data set with a large amount of variation, the observations will be on average far from the mean. Far from the mean. I referenced that on the front, right? This has a high variation because these values are far from the mean. In contrast, we have a low standard deviation is when a data set with a small variation, the observations will on average be close to the mean. Like that data set that had all 5s. They're all the same as the mean. So can't get any closer than that. The pro for the standard deviation is preferable to the range as a measure of variation because the standard deviation takes into account all of the observations, whereas the range considers only the largest and smallest. The con is that the standard deviation is not resistant to outliers. Kind of like the mean, right? Since it relies on the mean isn't resistant to outliers, therefore the standard deviation is not resistant to outliers. I'm going to pause it here, so we're going to all practice doing another data set calculating the standard deviation.